Okay, on this one, a tiger leaps horizontally from a 7.5-meter high rock with a speed of 4.5 meters per second. How far from the base of the rock will she land? So in this case, first thing you want to do is draw the problem. So we got a little tiger here. Hello. Uh, Give her some spikes too. Well, I guess those are like wings. Maybe she's flying. Anyway, it's jumping straight out at 4.5 meters per second. So no original speed in the y direction, just jumping completely horizontal, which helps to simplify the problem. And we also know that the rock was 7.5 meters high, which means your delta y, how far you fell, is you went down 7.5 meters. So delta y is negative 7.5. The process that you're going to use for pretty much any time you have something flying through the air is you're going to break it down into two problems. You've got the motion of the object in the y direction going up and down, and you have the motion of the object in the x direction going left and right. The thing that links these two is time, because the tiger's going to spend just as much time going to the right as she does going down. Those two times are going to be the same because if you click the stopwatch and then she jumps, it's 1, 2, 3, splat. Well, both of these times are going to be the same, your time going down and your time going right. So t kind of links these two. So once you've found t, you know that you've finished one problem and that you're ready to go to the next. So in this case, your motion in the y direction is what you want to start with. And you'll get the hang of which side to start on after practicing some of these. So we go to our handy equation for when we have something accelerating. Delta y equals 1 half at squared plus vit. And this problem was nice and friendly because the initial velocity in the y direction, remember this is the y problem, is 0, which means we get to kill this term. No quadratic formula. Always love that. So it simplifies to just delta y equals 1 half at squared. So delta y was negative 7.5. And since the acceleration is minus 9.8, well, half the acceleration is minus 4.9 times t squared. Divide both sides by negative 4.9 and then take the square root, and you should agree with this time. So now that we've solved for the time, we toss it in the motion in the x direction, because that's what we're really after, is how far away in the x direction she lands. So since your speed is 4.5 meters per second, and you spent 1.24 seconds in flight, simply multiply those two and you get that she landed about 5.5 meters away from where she started, which is pretty realistic. You jump off a cliff that's 21 feet high and you manage to land about 15 feet away from it. That sounds about right.